about.
They're saying if you're electrically qualified, you have to have in your facility CPR first aid training.
Yep.
They're gonna ask me that when I get back.
You will get CPR trained when you get back. You already know that.
Yeah, but they were
Yeah.
still debating, I don't know if it was just, it might even be everybody complaining, I just sat in a seat.
The OSHA requirement also states that, and we can dig into that real deep if you want, there's some requirements under 1910.269 that require specific, they have specific requirements for CPR and first aid training. And the bottom line, what it boils down to is if there's a greater than 4-minute response time from any local responding agency, fire department, paramedics, things of that nature, that's when you have to have people on site trained. And the people who are doing the work have to be trained as well. So that's kind of where the OSHA stuff comes in, as well as the 70.
Yeah, I was concerned about the people doing the work. We have, on site, we have everything.
Right. If you do energized electrical work, you're going to have a second person there with you anyway.
Correct.
So your second person has to be CPR first aid trained. And trained in methods of release we talked about yesterday. Either knowing where the power supply is, or using a hook stick, or whatever the facility requires. Because that's part of your requirement on site. Yes.
If you have 2 people on site and they're both trained,
Mhm.
and it's required to do CPR, is there a penalty for the person if they choose not to do that?
There is no legal penalty because it is, what's the term that they've got now? You tried to render assistance, or you didn't, it's not, you can't be fined for not. You cannot be penalized for not rendering assistance. But you must call someone.
Okay.
You have to call someone. If 2 people are working, both of them are CPR trained, the first one goes in and the person down. The second person, what's the first step you want that second person to do?
Call for help.
Absolutely. First things first. Always call for help first. Beyond that, there is no criminal offense if you refuse to render aid.
Kind of like the Good Samaritan Act.
That's Good Samaritan law, that's right,
Okay.
that's what it was. Yeah. Okay.
Yeah, because I've been in a couple classes where people have said, yes, we're required to take this training, but I don't think I can do this.
Yeah, right. And that's something that you, as a person, you personally have to decide.
Right.
What's the worst that can happen if somebody goes down after being electrocuted? Okay, let's talk about the difference between receiving a shock and being electrocuted. Are they the same? What's the difference then?
You're shocked when you can still function. If you're electrocuted, you cannot.
Electrocuted is dead.
Right.
Yeah.
There is no coming back. Shock means you've received an electrical shock, you've received electrical current. If you have been electrocuted, you are dead. Bottom line. So even something is not going to harm that person anymore. Even chest compressions is not going to harm that person anymore. Okay.
Okay.
All right, anything else? No? Okay. Well, let's get started on electrical lockout tagout. We talked yesterday about your lockout tagout program. You thought was a pretty good program where you're located, right? Anybody that is exposed to any type of electrical hazard. Now what's considered an electrical hazard? We looked at the pictures yesterday where it showed normal and abnormal conditions, right? What was the difference between those 2 pictures? Normal means what?
Normal operating procedure.
Normal operating procedures.
It's enclosed.
All the covers are in place. All the screws are holding the cover in place. The minute you take those covers off, you are now in an abnormal operating condition. You have exposed energized conductors. You've got the potential for making contact with them. Okay? The minute you pull those covers off, what has to happen?
They have to put PPE on them.
Before the PPE is even put on, what do you need to keep, who do you need to keep away from there?
Unqualified.
Unqualified persons, right. You gotta make sure that your unqualified workers are there, or are kept away from there. Okay? Locks and tags. Or locks have to be tagged, tags have to be tagged, right? But how do they have to be identified? Who has to, locks have to be identified with what? Your name, who it belongs to. Some companies have a photo ID that attaches to it.
Yeah.
Some companies just have a band around it, around the base of the lock, that says this lock belongs to whoever, do not remove, and all that other stuff. Right? So, the lock can only be removed by the person that attached that lock, right? Are there any scenarios where someone else can remove that lock?
If you do not work for the company anymore,
Okay, if you don't work for the company anymore,
So that you come, say like the shift today you worked,
right?
you went home, you got in a wreck and you're hospitalized. Or
You can't return to the job
Right, you
site.
can't return to the job site, so your supervisor would be able to take
Right.
that off.
How would he take it off?
Normally, a supervisor, we have locks, we have a set of keys for each of the guys' locks in case something happens.
Okay,
And we
we'll
would
talk
go
about that in a second as
Yeah, what
well.
I'm gonna say is we'd go through our base safety on that issue as far as removing that into
Okay.
the circumstance and get their authorization.
There's a written procedure that you follow, right?
Correct.
Okay,
Normally, on our base, we're working an 8-hour shift, and at the end of this shift, if it's still gotta be locked out, tagged out, then I would put we would change out the individual's lock and put my supervisor lock on that, in case
Okay.
something happened. You see what I'm saying?
right.
That's a procedure.
So that's a turnover scenario.
Correct.
Where that 8-hour worker would do a turnover of that lockout process.
Correct. If it goes beyond a normal shift, then the supervisor's lock goes on.
Okay,
And that's base procedures, but if someone was injured and couldn't make it in, then you would have to go through base safety for the authorization, and they either say yay or nay or what.
Okay.
It's their decision.
that's their,
And that's how that's our.
and that's the base written procedure.
Correct.
Absolutely. So what you need to do is follow your written procedures. Tim, you've got written procedures you're going to get into when you get back there through your lockout tagout program. But what it boils down to is this. The person that attached the lock is the person that removes the lock. There are various exceptions to just about every rule, but bottom line, you put it on, you take it off. All right? Who is authorized to work on circuits that are over 50 volts? One word I want to hear.
Qualified.
Qualified, exactly right. And remember that 50 volts. We talked earlier yesterday about the 50 volt limit. What level of current can cause ventricular fibrillation? What was that number yesterday? How many milliamps? 75 milliamps at 1,000 ohms, right? So the human body can have resistance as low as 1,000 ohms. And at 50 volts, how many milliamps is that? 50. Is that below the 75? So there you go. All right? Does it make sense that whoever that qualified worker is capable of working safely? You have to make sure that you're not going to have a qualified worker who does not work safely, right? You got to know what your procedures are. You have to know what those hazards are. What are some of the requirements for becoming a qualified person?
training.
What kind of training? I know that was coming up, but what kind of training? You're absolutely right. Training in recognizing what?
Hazard.
The hazards, that's one. How to determine
The proper testing equipment.
Proper test equipment, okay?
Choosing the right PPE.
Choosing the right PPE. Mike? Determining nominal voltages, you gotta remember that. In order to know what proper test equipment you need, you have to know what the nominal voltages are that the equipment's operating on, right? Okay.
Don,
Yes?
forgive me for appearing ignorant, but I've always heard that word nominal, and I've never understood what it was, what it meant. Nominal.
Nominal,
Present?
not necessarily present, but nominal, we'll interpret that right now as normal operating voltages.
Okay.
If you've got a piece of equipment that operates at 120 volts, your voltage may read, with a digital voltmeter, it may read 122, 123, maybe 118, but the normal nominal operating voltage is going to be 120. Same thing with 480, something along those lines, okay? Nominal is going to be normal operating rating.
Thanks, sir.
Sure. Okay? What else we got? 130.6, alert. Alert, alert, alert. What does that mean? What's another word for being alert?
Being aware.
Being aware. You have to be aware of what the potential hazards are anytime you're working on equipment operating at 50 volts or more. What's the number one potential hazard that we've been talking about? The most common one. Shock hazard, right? Don't get yourself in a scenario or a situation where you can come in contact with those live parts. Make sure the covers are on. If they are not on, you have to make sure that you have all the proper protective equipment. You have to have barricades set up. We're going to talk about it in just a minute. This is a good one. When impaired, make sure that your people are not impaired when they're trying to work. And what does impaired mean? What's the first thing that comes to mind when you think someone is impaired and unable to function safely and properly? What's the first thing that comes to mind?
Leroy.
Handicap.
Handicap, meaning
Unable to perform a certain duty or task based on the limitations of.
their physical limitations. Okay, I'll buy that.
Ron Jenkins.
Could Ron drinking, consuming adult beverages, would that be impaired? Sure. What else? That's usually the first one that comes up.
You could be on medications,
Medications.
because, there's a lot of people taking medications daily
Absolutely.
that are prescribed.
Absolutely.
Some of that can cause other effects.
Oh, you bet it can. What else?
Sickness.
Sick? You got the flu,
Come into work feeling pretty good and you start feeling lousy.
feeling kind of puny when you get to work in the morning, and then as the day wears on, it's just, don't feel good. What
Overly
else?
tired,
Pardon?
overly tired,
Overly
fatigue.
tired. Absolutely. What if you're on a 14 or 16-hour day and you're in the middle of a process or project? You think you're going to be as sharp as you were when you first got there in the morning? Chances are you're not. So make sure that you're not impaired in any way. Be it tired, under medication, whatever the case is, make sure that you're not impaired, because that's going to cause you to get yourself in a situation where you can get yourself and somebody else hurt. Okay? Now, the safety programs that your companies or your facilities are going to have in place is going to outline a lot of different things before you begin work. The first thing you do, what did I tell you you have to do before you start any job? I said yesterday, there's something you need to do.
Assess the hazards.
Assess the hazards. Look for a way to get hurt, and then don't do it that way, right? That's also called a job briefing, or that's part of a job briefing, to do your hazard assessment. You look at the job, you write down what the task is. There's a briefing sheet that you can use. There's one in the back of the 70E as an example you can use. You can develop your own. These documents that are in annex, the annexes in the back, they are not required documents, they are examples, okay? You can draw up your own, but the main thing you want to look for is the task analysis. What are you going to do? How are you going to do it? What's going to be required? What are your safety equipment? What are the proper tools you're going to use? Things of this nature. Do your job briefing before you start. Remember that little mom and pop shop I told you I used to work for in Albuquerque called Intel? They had a little thing called a pre-task plan, which was a written form. You plan your job and then work your plan. Step by step, everything, and if conditions change, what do you need to do?
Stop.
Stop. Take a time out, back away before you get yourself in a situation, and then redo your plan again. Do your hazard assessment all over again. What would be the situation where conditions might change? Let's say we're all working in this area and we're installing a new lineup of switchgear up against the front wall.
Unexpected shutdown, loss of power from the plant.
Loss of power, big time. That's a big one.
Construction crew working down the block, maybe affect the power downstream. or
You're
something.
right. Somebody else doing other work, maybe not even in your location. But what if you've got welders that are working in your area? What if you've got sprinkler installers and you're installing switchgear? What's one thing that doesn't go well together? Water and electricity, right? Okay, so if the work area changes, if you get a new crew or somebody else new on the job,
You could be following your design as the installation and it not match what's there.
Uh-huh.
It's a complete stop in.
absolutely. Do your design plans always match your as-bills? No. Why not? Because you may have a half an inch, not enough room to put that lineup of switchgear in. Is it gonna fit now? What can you do to make it fit?
Where you back up and discuss it.
Okay, let's take a time out and figure this out. Let's call the designer in and say, look, your measurements were off by a half inch or whatever. Your situation has changed, you stop and make that assessment. Other work in the area, work on the same circuit, emergency response communications, any of these things change in your job briefing, you need to stop. Okay? If it's the same task over and over and over again during the same day, do you have to stop before each task and redo your task plan again all over? No. If it's a repetitive and it's the same exact task, if there's something different about it, you need to reassess, all right? All right, Ron, you guys have overhead power lines, don't you?
Yes, sir.
You were telling me all about that yesterday with your workers around there and people in the yard, you know, picking mangoes out of trees with aluminum poles and stuff, right?
Let's leave it right.
Oh, he was doing it? Okay. Unqualified persons with overhead power lines. Are those mango pickers qualified electrical workers?
No, they're not.
Then why do they continue to get electrocuted or shocked?
Ignorance of our, I won't say ignorance, but I'll say unfamiliar with what's around them, surroundings.
There you go. Their surroundings.
Right.
They're not familiar with their surroundings, and people tend to focus on one thing that they're doing, so they do it right. They don't have the peripheral vision or the knowledge to look around. Okay? So that's where people can get in trouble. Your overhead power line's minimum clear distance for unqualified persons at 50,000 volts is 10 feet. Minimum clear distance, 10 feet. For every 10,000 volts over 50, you increase that by 4 inches. So if I got 70,000 volt overhead power lines, what's my minimum clear distance? 10 feet, 8 inches, there you go. Got it? 80,000 feet, 80,000 volts would be 11 feet. Okay? Just keep adding 4 inches for every 10 kV above 50. Now, that's for unqualified persons. Qualified workers have different requirements. They can get a lot closer than that, can't they?
Yes.
Why would they be able to get closer?
They're qualified, they're familiar with surroundings and the hazards that are there. They're trained.
There you go. They've had the training, they know the surroundings, they know the hazards. Supposedly, they know what they're doing, right? Okay. If you are moving a truck, a crane, a dump truck, near overhead power lines, like we talked yesterday, dump truck goes up like this and pulls forward, takes out power lines. Crane making a swing around an area. Minimum 10 feet. Okay? Now what does this mean? It says may come within 4 feet if it's in transit.
In transit, meaning that the boom and everything's not operating, that it's,
Down and in the cradle,
and in transit moving.
you're driving.
Correct. You're not, it's not operating for work, it's in the, you're driving it from point A to point B.
The minute you stop that vehicle, what's your minimum distance? 10 feet, because it's no longer in transit. Okay? And again, that's at that 50,000 volts. Okay?
Oh, yeah.
Wow.
That's dinner.
Is that where you had dinner last
Looked
night?
like last night's dinner. On the right was a dog, on the left was a cat. Tell the difference.
And you couldn't tell which was which.
Mm.
All tastes like chicken.
Yeah.
All right, illumination. Who was it was telling me yesterday that they had somebody that was reaching up into a junction box up on top of the, couldn't see what he was doing? Was that you?
That was my boss, went off that 12-foot ladder.
Yep. Don't reach blindly. That means reaching into a place that you can't see. If you walk into a, let's say power goes out right now. We're not doing too bad because we've got windows and we get a little bit of sunlight in there. But if you're inside a building and power goes out, what's the best thing to do? Don't move. If there's any potential for exposed conductors, energized parts, don't move. Because you could become disoriented and walk right into it. Another thing you don't want to do is reach into a dark room to try and find a light switch. You don't know what's in there. Coming into an office building like this, usually the light switch is going to be right inside the door, and there's not going to be a lot of exposed parts unless work is going on. But you get out into a substation or into a motor control center room or an electrical vault, there's always the potential for something energized to be exposed. Okay? This is where we get into that, don't enter spaces unless you've got temporary lighting. What's the best form of temporary lighting you can have?
Flashlight?
Have a flashlight. That's the simplest one, right? Lack of illumination, we talked about that. Does anybody in here do confined space work? You do, you do.
Permit.
Permit required. You said all your electrical vaults and manholes were all permit required confined spaces, right? Who determined that they were permit required?
Marine Corps safety.
Marine Corps safety. And yes, sir, I'll follow that to the letter, right?
On Marine Corps bases, domestic and foreign,
Okay.
they set the standard.
Well, what's going to determine whether aside from the Marine Corps saying it's permit required, what else would require or would determine whether a space is a permit required confined space versus a regular confined space? What's the definition of a confined space to begin with?
Limited entry point.
Limited entrance and egress. Okay, so it can be one or it can be two, but they could be 50 feet apart from one another. That would be limited. What else?
Hazards.
Presence of a hazard?
What kind of a hazard?
Be anything, chemical, electrical, gas,
Chemical, electrical, gas. What about an open
Thermal.
trench?
yeah.
Open trench, you could have engulfment. Okay, what else? Huh? Any idea? Okay, next. Okay. So you've got limited access and egress. You've got the potential for hazard, not necessarily a hazard in there. The main thing is it's not designed for continuous occupancy. Remember that now? Not designed for continuous occupancy. That means it's not designed for you to stay in there all the time. Okay? And it has to be big enough to enter. Just reaching your arm into an empty void that you cannot physically enter, that doesn't make it a confined space. In order for it to be considered a confined space, it has to be physically large enough for you to get into. Okay? When you are in a confined space, in the manholes, why do they make manhole covers round? There is a legitimate reason why they are made round. You have any idea what that is?
Cover is harder to pop off
Not really.
from running it over. If it's rectangle or square, you run it over, 90% of the time it opens.
It could, yeah, but that's not the main reason.
Access,
Access, no,
restricted access.
no. Whether if it's round, it doesn't matter, it will not fall into the hole. If it's got the lip that's gonna hold it in there round, it's not gonna drop in. If it's square, it has the potential for dropping into that hole. It can go diagonally, it can go a long way, and it'll drop in the hole. But if it's round, there is no way it's gonna drop into the hole. Does that make sense?
I like mine better.
Oh. Okay, then yours is the right answer, Leroy.
Sorry.
On your test.
On my test, what's the answer?
Does
Your
not
answer.
drop in the hole.
It won't fall in that hole.
There you go. Anytime you have doors or access panels, when you're entering, you have to block them open or remove them so they don't close on you. Okay? You folks ever work construction of any type? Installation? Repair? Carry 10-foot pieces of conduit? Sure. You can see the front end of it. Can you always see the back end? Uh-uh. Make sure you're aware of your surroundings and where both ends of whatever it is that you're carrying, if it's conductive, make sure you know where both ends are. Since we're talking electrical safety at this point, we're talking conductive materials. Let's talk about general safety. I'm carrying, 20-foot 2x4 on my shoulder. I've got 10 feet in front of me and 10 feet behind me. What happens if I turn to look at somebody? You don't know where that other 10-foot section is going, do you? And hopefully Leroy won't be standing there.
Picking mangoes.
Picking mangoes, there you go, out of real tall trees. Okay. Fuse handling equipment, this is always a great one. Use the proper tool for the job. Boils down to that. Use fuse pullers to pull fuses. Does that make sense? How many folks in here, and don't tell me, have ever used channel locks or lineman pliers to pull fuses? It happens, doesn't it? Wrap some electrical tape around the jaws, reach in and grab it, or not even wrap tape around it. You don't even wrap tape, right? Well, what happens if you reach in there and pull them out? Sometimes those channel locks or those fuses can blow up on you. You can see where these are the old fuses that were in the panel. I'm going to have to learn how not to touch that screen when I'm pointing. Okay? You can see where the arc points are right here. All right? And guess what happened? It just blew the top right off of that fuse, didn't it? That's the proper type of fuse pullers. The yellow ones are the older style. I've still got some of those. I'm used to them. They make different types of fuse pullers, different sizes for different size fuses. Yes?
One's on the left, I really don't, I prefer the one on the right.
You
Because the
prefer
ones
that
on-
one?
Yeah, because the ones on the left are flimsy to a point. Real,
No, the plastic?
oh, yeah.
Yeah, if you get it tight.
Yeah, trying to get a grip, it's flimsy,
Oh, yeah.
but the one on the right is solid as can be.
So
Yeah.
grab the channel lock, man.
No, don't grab the channel locks. Or needle nose either. All right? Portable ladders. Non-conductive side rails. What's that mean for electrical work?
Fiberglass.
Fiberglass. No aluminum ladders, right? Unless you're a painter. Right? Conductive articles, we talked about yesterday, rings, watches, necklaces. What about glasses, eyeglasses? We talked a little bit about that as well. Goggles or the face shield if you're going to be working on something live, right? There's no issue if there's no exposed live parts. Cell phones and pagers. Cell phones and pagers. How many folks in here have their cell phone on them when they're working? On your hip. You guys wear a cell phone out in the field?
I leave mine in the vehicle and I get in trouble for that.
It's like an appendage. I mean, you're supposed to have it on you.
It's an
24
electronic
hours
leash,
a day,
isn't it?
7 days a week.
Okay?
Well, in ours, we each have a radios that we carry,
Mhm.
communication. But we have a area there we can't, so they've issued the Nextel for walkie-talkie.
Oh, the Nextel walkie-talkie style?
Yeah.
Okay.
For group, when we're switching and stuff and things of that nature.
Okay.
For communication purposes.
Anybody in here still have a pager? Okay, I guess you moved into the newer technologies then. I can remember a time where I had a pager on underneath my tool belt, reaching into a live panel, and somebody called me.
Oh, that's worse.
Somebody called me as I'm reaching into the panel.
I think we've all done that.
Guess what? My tools didn't touch anything, but they flew. Scared the living bejesus out of me.
I told you don't use that aluminum ladder.
It wasn't the aluminum ladder, I was standing on the ground. Okay? All right. Conductive jewelry, we talked about that. Housekeeping. This pertains, yes ma'am.
Quick question. You were saying about eyeglasses, and actually
Mhm.
contacts too. What about hearing aids?
What about hearing aids?
I mean, would that be something that you shouldn't wear?
Are they conductive?
Yeah, because they're plastic or metal, and you got batteries in them, and
Okay.
so you would definitely have to remove those.
Not necessarily. If there is no potential for contact, this is what we're talking about, is conductive articles. If they're conductive, let's go back, must not be worn where they present an electrical contact hazard. Are hearing aids going to make contact with exposed live parts?
Well, if you fall,
It's possible.
mhm.
It's possible. If you're working in a piece of equipment and it's live, first thing, what are you going to have on?
well, you have your PPE on.
List the PPE you're going to wear. Tell me what you're going to have on as far as PPE.
Well, you have your, most likely your face shield and
Okay,
your,
face shield with a hard hat,
right, and your glasses, you know, your goggles,
safety glasses,
and hearing protection. But,
hearing protection. If you're wearing a hearing aid, what type of hearing protection are you going to wear?
well, you're gonna have to have the earmuff.
The Mickey
type of
Mouse
thing,
ears.
Yeah,
Okay. Where does that face shield surround your head?
it goes to here.
It goes to about here, about your
Yeah.
ears. Chances are extremely, extremely slim. If you feel you need to remove your hearing aid, can that cause more of a hazard? Yes.
Yeah, because you won't be able to, if there's any sirens or warnings or things like that that you should be hearing
Okay.
while you're in there.
Now, we're gonna go back to,
Kinda hard to get your ear in the live part.
look right here, look right here. Unless it's rendered non-conductive.
Okay, because there's some of them that fit on the outside That
Yep.
people, when they put stuff on and they don't have it adjusted properly.
Yep.
And I didn't know if anything with the frequency can do anything.
It has nothing to do with frequency or the voltages in the batteries
Mhm.
or anything like that. It has to do with the actual physical earpiece itself,
Okay,
okay? If it is rendered non-conductive by using the external monaural hearing protection,
Mhm.
the Mickey Mouse ears,
okay.
it's non-conductive at that point, okay? That's the key part right there. If it's rendered non-conductive, you're good to go.
Okay.
You can't hear, because they do all the sign language.
What?
We got a painter on the base.
Okay?
Every time we have meetings, they have the people doing the signing for
Mhm.
you. And I mean, you bring up painters, and I just thought about it, like, when he's out there working,
The painter who cannot hear, is he going to be working within that limited approach boundary area?
well, it could be anywhere.
Okay?
But I just thought about it, being that she brought that up, that when we have meetings, they have people come in, they sign for
Right.
him. I've never heard him talk.
He's under 88, there's certain regulations, rules
Right.
right out. Also, because he's working on the base, he's restricted to certain things he can and cannot do in his profession,
Right.
all right? It's like, he might go up to a barracks, do a room, do the outside of the barracks,
Mm-hmm.
but certain other things, there's restrictions that have been put on him by the base.
By the base.
But
And by
ADA
OSHA.
Right. There's certain things he can do, certain things he cannot do, in certain areas he can go into, in certain areas he cannot go into.
It all comes down to that one word, qualified. Just because he's a painter, does that mean he's qualified to paint anywhere in the facility? Qualified means what?
Who knows though?
Well, what's the definition of qualified?
Someone's been trained,
Been trained for what?
has it?
Hazard awareness, yeah, he may know what the hazards are, but is he able to react to those hazards in the area? Not necessarily. So he cannot be a qualified person for that area. It's like we talked about the landscapers yesterday.
Right.
The landscapers are out there pulling weeds out of the substation. They know don't get their hands up above this high. Or if the weeds are that high, you got problems anyway. But make sure, the people who have, who are in those situations know what their limitations are. Now, if he's out painting the outside of a barracks and an evacuation alarm goes off, is he going to hear it? Probably not. But what else is he going to do? He's going to notice other people around him.
Plus his lead that's with him would be the one
Right.
to notify him.
He's probably not by himself
No.
at all. So he's going to have somebody working with him. Okay? All right. Housekeeping, we talked about that. Interlocks. Who can defeat an electrical interlock? What's the word? Qualified, nobody else. And interlocks cannot be used as a means of isolation. That means you can't just use an interlock, a door switch, as a point of isolation. Like we talked yesterday with the guy up on the roof, is a photocell a form of interlock? Sure it is. What about door switches? Do they fail? You bet they do. Okay? Only a qualified person can defeat those interlocks temporarily for troubleshooting. Once it's done, it has to be returned to their normal operating condition. All right. Any questions up to this point? No? Okay. Portable electric equipment. This is one of my favorites because everyone in here, I don't care who you are and how safe you've been, everyone in here has done this at one point or another. Portable equipment must be handled in a manner in which it will not damage the equipment. Okay? What are we talking about here? Has to be visually inspected, have to have flexible cords with a grounding type conductor in them. And what's one thing you don't ever want to do with a portable tool that has a cord hanging by it? or the head you
Carry
plug
it by
in.
the cord.
You don't carry it by the cord. Okay? And how do you unplug an extension cord?
You walk to the male end and pull it out.
Walk up
Starting
and-
to moor.
You yank it from across the room,
I
right?
think you're starting to moor.
And whip it out of the wall. I know somebody that did that. And that cord cap came right back, busted him right there across the lip. I laughed. Didn't do it again though. Because that hurts. You get a cord cap from a male plug coming out of the wall. What else is happening when you're jerking on that plug? On the receptacle? What are you doing to the receptacle? You're stressing it. You're gonna break that thing.
You can weaken the tension on the prongs on the inside of the receptacle.
You can weaken that. What are they made out of? Plastic. If it's bound up in there, or if it's a new receptacle, those things are tough to plug into to begin with. Okay? Double insulated tools, only has a 2-prong, not necessarily have to have a grounded plug. Excuse me. But if you're using an extension cord, there has to be a GFCI receptacle. Now, where are you going to put that ground fault circuit interrupter? At the drill or at the point you plug the extension cord in? Which end of that extension cord? The male end or the female end?
We,
Female?
yeah.
That means the drill end, where the drill plugs in?
No, where it plugs into the
Or it
wall.
plugs into the wall?
Yeah.
The source.
Always put it
Where
at
it
the
plugs into the
source,
wall, yeah.
because you want to protect that extension cord from failure.
Sometimes you get a receptacle that's not gel CI.
Mhm.
You have the gel CI. that-
These up here.
Right, that you add into the system.
Yep. Okay? Here's your extension cords.
This is an alleged purse snatcher running from police near Houston, Texas Wednesday. They got him.
It's been raining this morning. As the truck was applying its brakes, it did.
Fine condition for being
He's
put
in
in.
wonderful shape, isn't he?
Looked like those, the rear tires ran over.
Both
Well,
of
it was
them,
the
both
front tire
front
and rear
rear.
tire, but you can see where the truck was sliding. He said it was raining, you could see where the truck was sliding. He just ran the wrong way in Texas, and stuff happens, right?
They don't do that in
Don't
the-
snatch a purse.
1993, Alvin Potter and Jarvis Bunt finished repairing a
I've seen
water
this
heater
one, yeah.
in the plant cleanup area.
Well, the cord was laying on the floor where we'd been using it, and Alvin didn't see it, just ran over.
Whoa. Look at this. Take that cord and get another one. I'll meet you at the other station.
I decided to fix the cord myself. I had an extra plug in the box, and by the time I put the plug on the cord, Alvin had the tools over to the next job site. We were ready.
Plugged in.
I didn't mention to Alvin that I rewired it, and I thought I did a good job, but I rewired it wrong.
What happened?
Bad saw.
No, saw cut really well.
He's getting shot
Why was he getting shot?
because they wired the cord wrong.
Okay? In an extension cord that had a 3-conductor extension cord, what color are the wires?
Like black.
99.7% of the time. Black, white, and green, right? What do you think happened? He put the black wire on the ground. When he put the new plug on, new cord cap on the end of it, he put the hot wire on the ground. When current travels through that conductor to the tool, it energized the case of the saw. And what happens when current flows through your muscles? What does it do?
Contract.
It contracts and tightens grip. He couldn't turn loose of it. He dropped whatever he was cutting, and the saw fell. He couldn't turn loose of it to stop the saw. Okay? So, who can repair cords?
The mayor's qualified.
Only qualified, right? You think he was qualified to repair that cord? He just figured he's trying to help his boss, right? Doesn't always work out to the best, though. Inspecting portable tools and cords. Do a visual inspection for any sign of overheat. What happens to a conductor when it overheats? What happens to the insulation? Gets real soft, turns color, begins to melt. It discolors, you will be able to see that. Make sure that the cord is secure to the tool or to the cord cap. Make sure that it's not pulling out. I'm sure you've seen extension cords that have got the big round plugs on the end of it where the wires are pulling out of it. That's not secure. Make sure that you have that thing reassembled properly. Check for any cuts, missing ground prongs. I told you about this, the OSHA inspection I went through in Oregon a few years back, where the only citation we got was for a broken ground prong. If it's taken out of service for repair, make sure you get it tagged. Mechanical inspections, make sure that all your tools operate properly, make sure that the trigger switches don't stick. Okay? Weird noises. Excessive heating while it's running. What happens if a tool's starting to overheat? What's happening to that tool? It's breaking down the insulation. You break down the insulation either in the cord or in the tool casing itself. That means the motor's going to fail, and if it fails, it could possibly cause you some serious injuries.
Your first amp, $200. Your first strap, $30. Your first guitar, $450.
What if I try it?
Rock and roll, priceless. There are some things money can't buy. For everything else, there's MasterCard. Accepted everywhere music is.
That looked like Kyle Busch.
Sure it wasn't Jimmy?
You didn't see
He
when
wouldn't do
Kyle-
anything that stupid.
Kyle won that race, and they gave him that guitar and he smashed it. They got pissed.
Yeah.
He should have been fined big time for that.
It's his, he can do what he wants with it.
I mean, I guess he's probably got enough money to buy a new one.
He did, he bought like 4 more plus,
Yeah.
but it was a big stink about that.
Electrical burns get worse before they get better. Let me ask you a question. When electricity flows through a conductor, when current flows through a conductor, what happens to that conductor? What does it physically do? It heats up, okay? When you pass excess current through that same conductor, what happens? It heats up even worse, and it will fail, right? That's why you size conductors properly. How does the human body work? How does it work? Electrical current, right? The nerves. But we're talking microamps of current in the nervous system. Not even milliamps, microamps of current in the nervous system. So when you pass excess current through those nerves and through the muscle tissue, what's happening? They're heating up and they're beginning to fail, right? When something heats up, it's also going to begin to swell and enlarge itself because of the heat. Electrical conductors are designed to dissipate heat very quickly. The human body is designed to retain heat. It does not dissipate heat like a conductor does. That's why these electrical burns are a lot slower to heal, because it'll retain heat. Any type of burn that you receive, what's the first thing that the paramedics or the EMTs do to any type of burn?
Something cold on it.
They get something cold on it. They try to cool that burn down. Why?
Because it's constant, it's cooking.
It's cooking. That's exactly right. You're cooking the muscles. You're cooking flesh. You want to stop that effect. So you cool it down. When you take a roast out of the oven, does that mean as soon as it's out of there, does that mean it's done cooking?
Internally, it's still cooking.
It's still cooking. It's still hot in there. Same thing with an electrical burn. Current flowing through there is going to generate heat. It's going to continue to get damaged. Okay? You see the swelling here. Point of entry. Point of entry probably here, point of exit here. So all this tissue in between here is still cooking. First thing you need to do is get something cool on it. Same guy, a few days later. It's getting worse. Like I told you yesterday, there's going to be some pretty good ones. We had some really good ones, or good being a relative term, but we had some pretty amazing pictures yesterday. All right, when you are plugging in portable tools, make sure you go up and plug them into the receptacle and pull them out from there, not jerk them by the cord.
There we go.
Great. Power tool safety. Not paying attention to how he's putting the tools together. October's playoff month, isn't it? Sorry. All right, load-rated devices shall be used for the opening, reversing, starting. What that's telling me is don't use a circuit breaker to turn on and off systems, to start or stop systems, except in an emergency. I don't know how many times and how many people do it. It still happens today, where you walk into the shop first thing in the morning, and what's the first person do when they get there? Start flipping breakers to turn the lights on, right? You get in there and look at those breakers. They're not rated as switches. They don't have a switch duty rating on them. If the device is rated as a switch, then you can use it. You'll see there's a designation on those breakers. It'll say SWD, switch duty. That means the contacts and the device itself is made stronger, heavier, and is more durable than a standard type of a breaker. What happens when you open and close contacts? What happens across those contacts? They draw an arc, absolutely. So if you continue to do this on and off and on and off, what's going to happen to those contacts over time? They're going to heat up, they're going to pit, you're going to lose the contact, and where it starts like this to begin with, you may burn off some of the contact and just have a small point of contact in the middle. The more you do that, the less contact you have in there. That switch will fail. If they are rated as switches, that's a little different story. They're going to be manufactured a little different. When a circuit breaker trips, what's the first thing you're not supposed to do? Just don't go out and reset it. A breaker trips for a reason. A fuse blows for a reason. Okay? So don't just go and, just because a breaker tripped, don't just go throw the switch. You know, throw the breaker and turn it off, turn it back on. Find out why it tripped. If you can't figure out why it tripped, you can reset it one time. As per the OSHA standards. You can reset it one time. If it trips again, then you have to shut the equipment down until such time as you figure out why. Overcurrent protective devices, be it fuses, breakers, anything like that, cannot be modified for any reason, even temporarily. Told you about those no-blow fuses I have pictures of, where they've got a piece of number 6 wire welded across, soldered across the contact points. Okay? All the qualified people can use test equipment, and who's going to qualify you? Who's going to determine that you're a qualified person? Your employer. That's it. I'm not going to do it, but your employer is going to do it. Flammable gases, anytime that there's any possibility of using flammable materials. You ever do cleaning of electrical equipment? Sure. What do you use? Typically, what do you use when you clean electrical equipment? Contact cleaner. Is that flammable? Oh yeah. I used to have some really good stuff before it was banned called trichloroethane. That was some of the best contact cleaner and electrical equipment cleaning solvent that was ever made, until they found out that it caused cancer and all other kinds of good stuff and bad stuff. And they discontinued it. It was extremely flammable. It didn't have to get much above room temperature, and it started to get volatile. Make sure that if you use any type of,
Well, once you do that, you have to either restart it now or let it go through its own.
okay, well, let's go ahead and take a break.